Welcome back, fabulous math people. Today we are going to talk about linear inequalities. We are going to graph them and talk about how to solve them as well, compound and simple linear inequalities. A linear inequality is something that is linear that involves inequalities instead of just equations. So instead of an equal sign, you're using less than or equal to, greater than or equal to, less than or greater than in your statements. Our linear inequalities are going to involve one or two variables. For instance, x is greater than a number, or y is greater than x plus some number, or something of those forms. And the highest power is one. Whenever you get to a power higher than one, you get into quadratics, cubics, and those types of functions. So linear is just having the highest power of one. Compound inequalities take on the form and or and involve more than one number. For instance, rather than just x is greater than 1, you have x is greater than 1 or x is less than 5. Those are compound inequalities. Here are two examples. Again, -3 is greater than or equal to x, or x is greater than 5. That -3 is greater than or equal to x is the same thing as x is less than or equal to -3. So x is less than or equal to -3 or greater than 5. And then this is a compound inequality. Notice that there's no or written. So that's the and. You write your ands like this. And notice that those inequalities are written in a certain direction. You always write your inequalities from least to greatest, and your ands are written with the less than symbols. When you're graphing inequalities in one variable, you do that on the number line. For instance, as if you were graphing on the horizontal x-axis. When you're graphing two variables, you do that on the coordinate plane because you're dealing with x and y, those two variables. Instead of just having an equal sign, remember we have less than, greater than, less than or equal to, greater than or equal to, and we need to represent that on our graphs using some sort of notation. When you're using number line, you can either use dots and shading, or you can use parentheses, brackets, and shading. It depends on which direction your teacher is going to ask you to go. On a coordinate plane, you're going to be using dashed lines and solid lines with shading. You don't use parentheses and brackets with that because you're talking about two variables. For instance, let me show you the two things that you would do with one variable. For inequalities where the value is not included, you use either an open circle or parentheses. For less than or equal to, greater than or equal to, you're using brackets because the value is included, as well as a closed circle. On the number line, you shade whichever direction your graph tells you to go. If you need to go greater than, you're shading towards the greater than. If you need to go less than, you're shading towards the less than. I put in the direction that makes the statement true because you need to follow the direction. If x is greater than 5, you're shading where all the values are that are greater than 5. In the coordinate plane, we are going to be using a solid line for included values and a dashed line for not included values. And you're also shading in the area that makes the statement true. On a number line, you're shading a direction on a line. In a coordinate plane, you're shading the plane. It's either above the line or below the line, or some sort of intersection where you're going to be shading for the coordinate plane. You need a test point to help you determine where to shade. My favorite test point is on the coordinate plane 0, 0. I cannot use 0, 0 if the line goes through the origin. I'm going to have to pick a different point if the line goes through the origin. The reason that I love 0, 0 is because it makes the X and the Y go away whenever you're evaluating. You substitute in 0 for X and 0 for Y, and you determine if you've made a true statement. If you've made a true statement, you shade where 0, 0 is, that side of the line. If the statement is false, you need to go to the other side of the line and shade there. I will show you what that looks like in just a bit. You can use either interval notation or set notation when you are solving your inequalities. It depends on what your teacher wants you to do. You need to follow the guidance of your book or your teacher and how they want that formatted. You should be familiar with both. They're both great. Interval notation uses parentheses and brackets. Set notation uses the inequality symbol with braces actually to say the set of all X values or the set of Y, whatever it is that you're dealing with. Okay, I've written some notation. I have the union symbol, I have brackets, I have parentheses, which I described earlier. If the value is included, you use brackets. If not, you use parentheses. Infinity is not a number. It's an idea. You're getting larger and larger or smaller and smaller without bound. You cannot include the value of infinity. So for instance, if I'm talking about all values less than one, so if I'm trying to talk about X is less than one, in interval notation, that means I'm going all the way down to negative infinity. And remember, I write things in order from least to greatest. So I'm going to use a parentheses, negative infinity up to one with the parenthesis. Infinity is not a number, I'm not including it, and one was not included because the inequality was a less than. I could have a situation where I needed to use the union symbol where maybe I am going up to a value and then going greater than that. For instance, I could say in union with 1 to positive infinity, which means that 1 is not something that works for this statement, but everything else is. So that union symbol just combines the two of them together. Set notation for this would be braces or brace, and then it is the set of X values where X is less than 1. I just put that inequality symbol there and I include the braces and the variable that I'm talking about. Let us now go ahead and solve some of these linear inequalities and then graph their solutions. We'll start out with some basics and then we'll move into a few more complex problems. Here I have one variable, I have just X, and I have a single inequality symbol. This is not going to be a compound inequality, which means I'm going to graph this on a number line. But I do have some work to do as I have variables on both sides of the equation. So I'm going to distribute, combine some like terms, and work through this. Distributing 4, I get 4x minus 8 minus 6 is greater than 5 minus 28 plus 7x. That's from distributing these pieces here. 4x minus 14 is greater than negative 23 plus 7x. Negative 8 minus 6 is negative 14, and 5 minus 28 is negative 23. I'm going to subtract 4x from one side and add 23 to the other side. (23 minus 14 is 9, and 9 is greater than 7x minus 4x is 3x. Divide both sides by 3, and I have 3 is greater than x. It's actually better if you write the variable on the left-hand side. So if I do that, I'm going to switch everything. I need to change the direction of the inequality as well. That means that x is less than 3. And the reason I say that is because I can then follow the arrow to match the arrow on the number line. When I graph this, I'm just going to do a few points. I'll throw 3 in the middle. This is a less than symbol, which means it is not included. I'm going to do an open circle at 3, and I'm going to go less than, which is to the left. Your teacher might want you to not use an open circle, might want you to use a parenthesis, which means that I would do a parenthesis here and go down this way. Set notation for this would be x such that x is less than 3. Interval notation would be from negative infinity to 3. Those are the two different ways that you could write your solution set. Now we have a compound inequality. I need to subtract 2 from all 3 components. I have negative 2, and then I have an inequality symbol, 4x plus 2, and then an inequality symbol and 10. I need to subtract 2 from all 3 of those pieces to get the 4x by itself. -2 minus 2 is -4, is less than, I have 4x left, is less than 10 minus 2 is 8. Now to get x by itself here, I'm going to divide each of those pieces by 4. -4 divided by 4 is -1. 4 divided by 4 is 1. 8 divided by 4 is 2. So I have a compound inequality here. Set notation would be x such that -1 is less than x is less than 2. Interval notation would be from -1 to 2. Again, I have inequalities with no equal signs here, and so I'm using parentheses. And now I need to graph that. I have open circles at -1 and 2, and it's a compound inequality where x is greater than -1 and less than 2, so I'm shading in between the two of them. Or shade out. If I was to use parentheses, it would look like this. And you would put that on the number line as well. Another compound inequality next. This is a little bit trickier. It's got some other inequality components to it. I'm going to subtract 3. 8 minus 3 is 5, is less than or equal to -5x is less than 10. Divide each component by -5. That means I have -1 is less than or equal to x is less than -2. But remember, I divided by a negative, so I actually need to switch the inequality symbols. But now I have -1 and -2. They're not in order from least to greatest here. I need to then rewrite everything, switching the symbols and the numbers. That means I have -2 is less than or equal to x is less than or equal to, actually, that's not a less than or equal to, it's just a less than. -2 is less than x is less than or equal to -1. Set notation. X such that -2 is less than x is less than or equal to -1. Interval notation is from -2 to -1 with the bracket because -1's included. And then when I graph it, I'm going to have bracket and parentheses and closed and open symbols. From -2 to -1, or like that. Now we're getting into a linear inequality with two variables, which means I'm going to graph on the coordinate plane. It would be better if I was on graph paper, but you get the general idea. You can graph however you graph. I can graph using intercepts. I can graph using slope-intercept form. I could graph using a table of values. I'm actually going to imagine this as an equation. I know I need a dashed line because it's a less than symbol, but I'm going to graph using intercepts where I make the x 0 and get the y value and make the y 0 and get the x value. If x was 0, then I would have 3y is equal to 12 and y would be 4. That means that y equals 4 is my y-intercept. If y was 0, I would have 2x is equal to 12, which means x equals 6 would be my x-intercept. And then I have a dashed line between these points. Now I need to know which side of the line to shade. 0, 0 is not on the line, so I can use that as a test point. That means I have 0 plus 0 is less than 12. Is 0 less than 12? Yes, it is. That means that I shade on the side where 0, 0 is. If that statement was false, I would go above the line. And yes, it does say less than, so you want to draw less than, but it's good to test your point. I have another linear in the coordinate plane. It's using y is greater than or equal to 2. Might look like you could graph without a number line, but we're going to graph this in the coordinate plane. Y equals a number is a horizontal line through that number. X equal to a number is a vertical line through that number. There's not X and Y, it's just Y equals. That means I'm going to graph a line at Y equals 2. Straight line across. Now I need to graph Y is greater than 2. 0 is not greater than 2. So I'm not going to be graphing where 0, 0 is. I'm going to be graphing above where 0, 0 is on the other side of the line. In our last statement, I'm going to have two lines together, and I need to find the region where they intersect for my solution. First, we have x is less than or equal to -3. It's just x, which means it's a vertical line through -3. If I was to shade, 0 is not less than -3. I need to shade on the other side of the graph then. I'm going to shade over here. Now the equation 2x plus 3y, I'm not going to graph that using intercepts. It's not the most friendly. I'm going to go ahead and put that in slope-intercept form. That gives me 3y is greater than or equal to -2x minus 3. Divide each of these pieces by 3, and I get y is greater than or equal to -2/3 x minus 1. I have a y-intercept of -1. And then I can use my slope to drop 2 and go right 3 and make another point. I can also go up 2 and over 3 to make another point. That's going to be a solid line because the inequality is greater than or equal to. Now I need to know whether I graph above that line or below that line. And if I test 0, 0, 0 is greater than -1. That is true, which means I'm going to shade above the line. When I have two lines together, the solution is actually their intersection region. So you see where the orange and the green overlap? That's my solution region. Here, and it's all of this. That would be where your solution is. Thanks for watching. I hope this was helpful. Have a great day.